Long ago, before time was counted, and stars had names, there stirred in the hearts of our distant ancestors a quiet yearning, an instinct older than fire, deeper than myth, the desire to understand. It began not with equations or symbols, but with the rhythm of footfalls across a plain, with the waxing of the moon and the ripening of fruit. Somewhere between the hush of nightfall and the rustling of leaves, they began to notice patterns. 2 stones here, 2 stones there, then none, then many. They did not yet know what they were building, only that something invisible was guiding their gaze, a hidden order in the wild tapestry of life. In those shadowy beginnings when survival meant movement and memory, the seeds of mathematics were sown in the counting of days, the measuring of distance, the tracing of seasons across the sky. Perhaps a mother in the shelter of her firelit cave tied knots in a string to track the moons that passed since her child was born. Or a hunter deep in the forest etched lines upon bark to remember where the herd had last passed. These humble markings, now lost to time, were the quiet breaths of a newborn science. As the world slowly awoke into civilization, so too did these early stirrings of logic and measure. In the sun-drenched lands of the Sumerians and the Nile-fed fields of Egypt, mathematics began to wear the cloak of form and purpose. Clay tablets baked beneath Mesopotamian suns bore the first written numbers, cuneiform scratches mapping trade land and stars. The Egyptians, master builders of stone and silence, developed systems to lay out temples and raise pyramids in reverent alignment with celestial bodies. Their geometry was not merely calculation, it was devotion made solid, a hymn in sandstone to their gods. And so, numbers became not only tools but companions. Symbols that remembered what human hands could not. A merchant could now measure grain with confidence. A builder could trust the angles of his plumb line. A calendar could predict the flooding of the river, and with it, life or famine. All the while, mathematics whispered its presence beneath the breath of empires. Far to the east, in the cradle of the Yellow River, Chinese sages traced harmonious patterns through nature. Yin and yang, balance and opposition, movement and stillness concepts that later wove into mathematical principles. They used counting rods and clever logic to divine eclipses and solve problems of trade of law of the heavens themselves. Numbers were not abstract there. They were forces almost alive, part of the great cosmic dance. As the world's great cultures bloomed like night-born flowers, the seeds of abstraction took root. In the palm-fringed Indus Valley, merchants inscribed symbols onto seals, unknowingly laying the groundwork for number systems we now barely remember. Later, Indian scholars, quiet and contemplative, would give the world something far more profound than trade calculations. They would imagine the void itself. Zero. A nothing that is also something. It would take the world centuries to understand the power of that gentle concept, the whisper of absence that changed everything. Westward, again, in the olive groves and starlit courtyards of Greece, mathematics underwent its first great awakening. The Greeks, lovers of form and thought, turned mathematics into poetry and proof. Pythagoras, half mystic and half mathematician, heard music in the strings of lyres and the spacing of stars. To him, numbers were not just quantities but truths, divine, unchanging, eternal. With quiet certainty, the Greeks asked not just how, but why. Euclid, with calm precision, gathered the truths of geometry into a book that would echo through 2,000 years. Archimedes, joyous in his discovery, ran naked through the streets, crying, "Eureka!" Not in madness, but in revelation, having glimpsed the invisible threads that held water and matter in balance. And Plato, ever the dreamer, declared that the highest truths were mathematical in nature, hidden behind the veil of appearances, accessible only through thought and reason. But even as Greek thought spiraled into the sky like the steps of a lighthouse, other lights flickered across the world. In Alexandria, a city where the Mediterranean kissed the desert knowledge from Egypt, Greece, India, and Babylon came together like rivers joining the sea. Scrolls whispered secrets in dim, incense-laced libraries. Scholars translated and debated, dreamed and preserved. And it was there, beneath oil lamps and marble colonnades, that Hypatia, one of the last great minds of the ancient world, taught mathematics and philosophy before the shadows of conflict dimmed her voice. As the centuries shifted and empires sighed into ruin, the torch of mathematics began to flicker past, now into quieter hands. But the story, dear dreamer, is far from finished. Even as the marble columns of Athens cracked and the scrolls of Alexandria fell silent under dust and fire, the flame of mathematics, though trembling, was not extinguished. It traveled eastward and southward, carried in the hearts of travelers tucked between the lines of manuscripts, whispered along the Silk Road like a sacred chant. In the golden hush of desert dawns beneath the domes of mosques, and within the cool stone walls of schools, a new era quietly began to unfurl. The Islamic Golden Age rose like a soft tide in the heart of the medieval world, stretching from the libraries of Baghdad to the observatories of Samarkand. In this new world of thinkers and dreamers, mathematics found sanctuary. The House of Wisdom in Baghdad, nestled among gardens and courtyards, became a beacon. There, translators worked in gentle silence, lifting Greek, Indian, and Persian knowledge into Arabic, preserving it, clarifying it, expanding it. It was in this age that algebra, a word derived from al-jabr, meaning reunion of broken parts, came into form. Muhammad ibn Musa al-Khwarizmi patient Meticulous wrote a book so clear in its logic, so universal in its insight, that it laid the foundations for algebra as we know it. He imagined equations not as puzzles, but as relationships, delicate, balanced bridges between numbers. And through his name, Al-Khwarizmi, the modern word algorithm was born, though he never could have imagined the worlds that would someday unfold beneath it. Numbers, too, took on new forms. From the sands of India came numerals, simple, elegant symbols that replaced clumsy Roman strokes. The scholars of the Islamic world recognized their genius and spread them like lanterns across continents. The numeral 0, that ghostly ring of nothingness, found a welcome home nestled gently among the digits. Now, great calculations could breathe more freely, dancing into the realms of astronomy and architecture. And so, beneath stars that shimmered above Persian domes, mathematicians like Omar Khayyam solved cubic equations while composing poetry that whispered of wine roses and the fleeting nature of life. Others, like Al-Tusi, pondered trigonometric tables and planetary motion, preparing the ground for revolutions yet to come. Their work, precise and poetic, was a bridge between civilizations, a lullaby sung across centuries. As Europe slumbered in the shadows of its early medieval night, the wisdom of the East patiently awaited rediscovery. And when at last the winds shifted, and the time came, those long-guarded scrolls traveled westward once more. Moorish Spain became a golden threshold. In cities like Cordoba and Toledo, the knowledge of 3 continents converged. Scholars bent over candlelit desks, translating Arabic into Latin, and through those translations, ancient truths came alive again. Fibonacci, an Italian traveler and thinker, wandered from the markets of North Africa to the cathedrals of Pisa, carrying with him the Hindu Arabic numerals and a sense of wonder. He wrote of rabbits and sequences of growth and recurrence, planting the seeds of mathematical beauty in fertile European minds. Slowly, then, the embers of curiosity reignited. The Renaissance dawned not with a sudden blaze, but with a deep, slow inhale, the kind a soul takes before awakening from a long sleep. Mathematics began to stir with new dreams. Painters in Florence drew upon geometry to bring depth to their canvases. Architects designed cathedrals that reached toward the heavens, their blueprints filled with arcs, ratios, and hidden harmonies. In quiet chambers, men like Nicholas Copernicus and Johannes Kepler used numbers to reimagine the heavens. No longer did the stars circle a still earth. Now, the earth danced in a celestial waltz, obeying laws that only mathematics could reveal. Galileo watched the pendulum swing, and in its rhythm he heard the voice of time itself. He measured, calculated, and challenged ancient dogmas, believing that the language of the universe was not Latin, but mathematics, a pure and elegant code spoken in angles and motion. And then came Newton. Isaac Newton, solitary and unyielding, studied the fall of an apple with the quiet intensity of a man hearing the heartbeat of the cosmos. Beneath his pen, calculus took shape not as a trick of numbers, but as a profound method for measuring change. With it, the world became readable in a new way. The arcs of planets, the tug of tides, the path of light, all could be written in the quiet, sure language of mathematics. And though another, Gottfried Wilhelm Leibniz, birthed the same ideas in a different land, and though they quarreled bitterly in letters and egos, both of their minds helped form the twin pillars of modern thought. Mathematics, once a simple echo in caves and calendars, now soared with the gravity of stars and the flight of light. But the journey had only just begun. The clockwork of the Enlightenment ticked forward, and in its mechanical beauty, mathematics found new expressions. Euler, with a mind like a symphony, connected ideas with effortless grace, complex numbers, infinite series, the elegant equation that joined 5 of math's most fundamental constants in a single breath, EP1 0 E is par plus 1 x 0 IP1 0. He wrote volumes upon volumes, as if the numbers spoke to him in dreams, and he merely transcribed their songs. As Europe bloomed into a world of reason and invention, the Industrial Revolution stirred beneath the cobblestones. Machines began to hum and clatter, and mathematics slipped into steel and steam. From weaving looms controlled by punch cards to engines measuring pressure and power numbers, began to move not just minds, but entire cities. Yet amid this clamor, there were still quiet minds, gentle explorers in the land of abstraction. Gauss, child prodigy, and prince of mathematics, whispered answers before questions were even finished. He saw curves in prime numbers, unseen geometries in the space between stars. And across time, others would follow, seeking, discovering, unraveling the threads that bound the world. Still, dear listener, the night deepens, and the tale has more to tell. The future was nearing a future both dazzling and strange. As the 19th century unfolded like a grand and intricate tapestry, mathematics entered a realm of deeper introspection. The questions no longer asked only what or how, but dared to ask why and what if. In quiet studies, lined with paper and ink, new worlds were dreamt, not with ships or swords, but with symbols, concepts, and an audacious curiosity. It was a time when boundaries began to blur. Geometry once tethered to compass, and straightedge broke free from the Euclidean cage. Mathematicians like Nikolai Lobachevsky and Janos Bolyai imagined strange new spaces, curved, infinite, and counterintuitive. They dared to ask what would happen if parallel lines never met or met everywhere. These were geometries the human eye had never seen. Yet, the mind could wander through them like a dreamer strolling unfamiliar landscapes under alien stars. At the same time, arithmetic, once thought so solid and tame, began to shimmer with uncertainty. Georg Cantor, a gentle spirit prone to solitude, peered into the nature of infinity, not as a single unreachable peak, but as a landscape of many hills and valleys, some infinities larger than others. His ideas were met with resistance, even hostility by those who could not bear to think of numbers as unknowable or infinite as the sky. Yet Cantor pressed on lovingly, naming his infinities and building their homes in the logic of set theory, sowing seeds that would not bloom until long after his death. This was the age of abstraction, of structure, of seeing mathematics as more than numbers and shapes. It became a music of ideas composed in pure thought. Groups, rings, fields, these became the new instruments. They described not the weight of apples or the arcs of planets, but relationships themselves, deep symmetries that echoed in algebra and geometry alike. In this century of luminous minds, women, too, began to rise, though history often whispered their names too softly. Émilie du Châtelet, who translated Newton into the French tongue of enlightenment, brought gravity to the salons of Paris. Sofia Kovalevskaya, brave and brilliant, broke barriers and solved equations with a grace that turned struggle into elegance. Their words, their numbers became threads woven into the great fabric of thought. And then into this grand unfolding, a tremor, a gentle but profound unease. The foundations of mathematics, which had seemed so secure, began to show faint cracks. Could everything be proven? Could mathematics itself be reduced to logic alone? David Hilbert, with stern optimism, declared it could. He posed 23 problems, like sacred stones upon a path, challenges for the new century to conquer. But as the new century dawned, a young man in Vienna named Kurt Gödel quietly picked up the threads of logic and wove a startling conclusion. With infinite care, he proved that no system, however complete, could explain all of itself. There would always be truths that could not be proven, always a veil that could not be lifted. It was as though a soft rain had begun to fall on the marble temples of reason. Not destructive, but sobering, a reminder that even in the kingdom of thought, mystery lingers. Still, mathematics pressed on. In war-torn decades, and hopeful ones alike, it transformed into new forms. With the advent of machines, not those of iron and steam, but of silicon and light, the very act of thinking began to be shared. Alan Turing, with quiet genius and tragic fate, imagined a machine that could simulate any process of logic. He laid the foundation for the digital age, not with wires, but with symbols, crafting a ghostly model of the mind itself. And as the world shuddered through the conflict and rebirth, mathematics found its way into every corner of existence. It described the curl of smoke and the swell of a heart. It flowed in currents of electricity and in the pulses of data between satellites and screens. Claude Shannon gave voice to information theory, letting words and images become bits and bytes, the heartbeat of the internet yet to come. In universities and laboratories, on chalkboards and computer screens, new branches blossomed. Topology, with its rubber sheet universe, taught that shapes could stretch and twist like dreams. Chaos theory revealed that in the tiniest flicker of chance, entire worlds could shift, reminding us that predictability was not always within reach, even when equations were. And somewhere high above Earth, in the cold silence of space probes and satellites, traveled paths calculated long ago by minds that had only paper and ink. The numbers, precise and patient, still guided them true, like ancient spells. Yet amid this ever-growing forest of knowledge, the human heart remained unchanged. Still curious, still longing, still asking questions beneath the stars. And so, even as the modern age roared with speed and screens and data streams, mathematics never lost its hush. It still lived in the folds of nature, in the turning of leaves, and the flicker of fireflies, in the hum of cities, and the silence between galaxies. Its story, our story, was not one of cold calculation, but of warmth and wonder. Of minds reaching toward the unknown, not with fear, but with love. But there is more still, dear dreamer. More marvels, more mysteries, and the final echoes of a journey not yet complete. And so we arrive at the final stretch of this long, serene journey, a path not toward an ending, but into a quiet horizon, where echoes shimmer and thoughts drift like feathers through time. In the modern age, mathematics has become more than a discipline. It has become a mirror, a lantern, a bridge across the seen and unseen. In shimmering laboratories and softly humming servers, mathematics continues to dream. Its pulse can be found in the vast, invisible architectures of the internet, in the choreography of stock markets, in the unfolding of weather across continents. Its patterns guide planes through the sky and encrypt our secrets with gentle precision. Its whispers are woven into the circuits of every phone and every cloud of digital memory. At the edge of the known, it dances with physics once more. In the vast equations of quantum mechanics, probability replaces certainty. Particles flicker between states like thoughts half-formed. Mathematics reaches to grasp these elusive truths, building scaffolds of complex functions and imaginary numbers, describing a world we cannot see, but can feel deeply in the fabric of being. In the soaring hopes of cosmology, it guides telescopes peering deep into the night, measuring redshifts and background hums, building theories of inflation and curvature of dark matter and dark energy, mysterious, invisible presences that outnumber what we know. Still, through all this, mathematics does not flinch. It opens its arms to the unknown, welcoming the dark with equations written in starlight. And then, in recent years, a quiet revolution. A new kind of mind was born not from womb or story, but from circuit and code. Artificial intelligence, shaped by mathematics, began to echo thought. At first, it played games and solved riddles. Then, it learned language, made art, dreamed of answers. Some wonder if through it mathematics has begun to understand itself, gazing into a mirror made of logic and electricity. Yet even now in quiet classrooms, and beneath the low hum of lamp-lit libraries, the ancient rituals continue. A student frowns at a chalkboard. A teacher sketches a circle. A child counts stars with fingers in the dark. The journey is never really over for mathematics, lives not only in the abstract and the immense, but in every moment of curiosity, in every question asked with wonder. For this story, though, vast is not the tale of equations or symbols. It is the tale of us, of beings who once scratched lines in the dirt to track the moon, and now send golden records into space, inscribed with the harmony of primes and the yearning of a species reaching toward the infinite. The history of mathematics is a lullaby whispered through the ages, a song sung by shepherds and scholars, sung in Sanskrit and Arabic, Greek and Latin, binary and beyond. It has been sung to keep time, to find truth, to cradle stars, to count the beat of a sleeping heart. And now, as the journey draws to a close, you may let it settle over you like the hush of dusk. Imagine, if you will, that each number is a candle, and together they flicker in the quiet of your mind, gently swaying with breath, gently dancing with thought. You may drift now, if you haven't already, into the silence between the syllables, into the spaces where dreams are written in invisible ink. For the past has been told, and the future waits, but tonight belongs to memory. Sleep, dear listener. Sleep with the stars of Pythagoras above you, the whispers of Newton in your ear, and the gentle hand of algebra resting over your heart. Let the constellations of curiosity shine behind your eyes. Let the rhythm of pi echo softly in your breath. The history of mathematics is not over. It sleeps now within you, and you cradled in numbers, and night are part of its dream. Good night.